Hello, my name is Mitya, and in this tutorial we'll go through the entire LightAct software so you can get a quick overview of where things are and start exploring by yourself. Okay, let's start with the user interface. So this is what we call a basic workspace, and you can switch between workspaces here. There are 4 that we prepared for you already, but you can modify the workspace in any way you want. For example, you also have these height, and all the windows are dockable, resizable, so you can basically adjust the user interface any way you want. And when you exit the software, the workspace is going to get saved. So when you reopen it, you're going to find it the same way you left it. Most actions in the user interface can be done either by right-clicking, where you have several pop-up menus that appear, or by simply dragging. These are the main actions that you will be using. Also, we have these menu icons, which allow you to bring up additional, usually settings in various places of the software. And also what is useful is this eye icon for info. If you click on it, you get the quick tips window, which then updates depending on where you click it, showing you the shortcuts. And also if you click on this button, you get the link to the user docs for that particular window. There's a top menu here with additional help links that you can explore, and here you've got the main 2 menus with various additional windows. Here obviously you've got project settings, preferences, and this is the more or less standard file menu. This is what we call a toolbar, where you have the tools that you can use primarily in the viewport. And another window that you'll probably be using a lot is the properties window, which shows obviously the properties of objects. Another part of the user interface that you'll be using a lot is this thing here, where if you click here, you get the performance window, and basically here you see the FPS, frames per second, and render time. This is the GPU load. Again, if you click on it, it opens up the performance window. This is what we call main control, freezes all the outputs, locks UI, useful for installations where you don't want anyone else to poke around the software. This part controls the master volume, and this part controls the master fade of the entire software. And when you'll have additional output set up, you can also control the fade of those individual outputs. Okay, so let's create our first small project so that we will learn how to map content to video screens, for example. So first, I'm going to create a video screen. You can do that by either right-clicking and select one of the few options that you have here, or, which is much more common, dragging from the toolbar to where you want the video screen to appear approximately. When you drop the arrow, you see this pop-up menu with these shortcuts. So you can either press, let's say, number 3 for a full HD screen, or you can, if you hold key 3, you'll just create the full HD screen. If I hold 1, it's going to be 4K, and so on. So we've really made sure that the workflow is as fast as possible. So let's now change the size of it a little bit. So if I hold Control and just drag, I can resize proportionally the objects in the viewport. Okay, we've created our first video screen. Now let's proceed with creating a layer. So if I right click in the timeline, this is the timeline editor window. If I right click, I've got these what we call layer templates, and we'll talk about why they are templates and not just layers a bit later. So I'm going to use one of the generative layers, and I guess a good one to start with would be the color grid. Again, there is a shortcut on the right here, and it says C plus left mouse button. So I'm going to create this one by left clicking here. But if I hold C and if I hold C and left click, I'm going to create a layer, color grid layer. So every layer template that we've provided, we call them stock layer templates, has its own shortcut. So V and left click creates a video layer. D and left click creates content input, which is for NDI, for example, and so on. And left click creates notch layer, and so on. So again, we made sure that the workflow is as fast as possible. Okay. So now we have a layer, and you see the preview here, which at the moment looks a bit funny, but that's going to change really soon. In layer properties, I guess the most important property is what we call mapping. And mapping property governs where the content of this layer will go to. So if I click here, and you see that at the moment I have just one mapping, which is called screen mapping. And of course, there's just one screen, and I'm going to click on it, and it's going to appear here. So what's happening now is that color grid layer is basically rendering directly to the video screen. There's a number of properties, as I mentioned here. So one interesting thing is resolution mode. So if I change which is set to from mapping. So if I change the resolution of this video screen, the resolution of this layer is going to change as well. So let's divide this one by 2. So now the resolution is 1920 by 540. And you see that resolution of this layer has also changed. Now, if I change the resolution mode to custom, I can have the resolution of this layer custom, so that now you see obviously that the resolution of the layer is smaller than the resolution of the video screen. But this allows me to demonstrate another important property of almost every layer template, is what we call clip mode. So pixel perfect means that the content is going to get rendered to the mapping, in our case video screen, in exactly the same resolution as it's being rendered. Fit means that it's going to proportionally fit to the mapping, so that it fills up at least one dimension of the mapping. Crop means that it's going to get scaled proportionally again, so that it fills the entire mapping. Parts of it are going to get cropped, of course. And stretch means that it's going to get stretched to fit the dimensions of the mapping. Now, there are a lot of these properties, and all of them are explained for every layer template in our user docs. Okay, so let's explore other types of mappings. At the moment, we have just one video screen and one mapping, but let's create what we call a thrower. Again, I'm going to just hold number 3, key 3 to create it. And I'm going to duplicate this screen by holding Shift and just dragging. And then I'm going to resize it. I'm going to change the resolution to something square and change this to 10 by no to 5 by 5. All right. And then I'm going to create a duplicate of that as well. Okay, so now we have 3 video screens, 1 layer which is rendering to one of them. Let's now create a canvas. Now, a canvas is something that is very, very useful. Canvases and throwers are what we call mapping types, and they're virtual mapping types, so they don't have a representation in reality. So let's see how they work. So if I drag from canvas to my new gradient layer, you'll see that the mapping dropdown got selected to canvas 1, and now this gradient layer is rendering to that canvas. By the way, a lot of layer templates have auto rename checkbox, which basically automatically renames the layers so that it tells you where it's rendering to. You can disable that, and then you can type in whatever name you want, but actually I like to have it enabled so that even by the layer name I can see what it's doing and where it's rendering to. So I'm going to render this grain layer to the canvas, and in here, that's something I did just before. If I double click on canvas maps window opens up. You can also access it here. Canvas maps window is designed to allow you to map content from canvases to various viewport objects such as video screens, projectors, or 3D models. In most cases, it's used to map content from canvases to various video screens. So if you drag from here to one of the screens, you see that the content gets mapped from the canvas to the video screen in the viewport. So canvas mapping is what we call it, allows you to map content from one layer to, for example, 2 video screens at the same time. It also allows you to, if I hold Shift and drag, to create sub areas in these canvases and map them to individually. You can also, of course, rotate it, rescale it, and what's also useful, if you right click on it, you can create a layout, which is something that we'll talk more about later. And if you click here, you have our node-based system where you can also adjust things like warping and things like that. This is something that we'll only touch upon in this video tutorial at this point and when we'll talk about layers. But at the moment, I guess it's enough to say that Canvas Maps window allows you to map content in various ways from canvases to viewport objects, primarily to video screens. There's another way to map, and that's mapping through throwers. So let's map color grid layer to the thrower. Again, I can just drag it like so, and I think you can also drag it like so. So now color grid layer is mapping content to the thrower, and I'm going to select pixel perfect and from mapping as a resolution mode. So if I select the thrower, you see that here in the thumbnail preview, you see that the texture is on the thrower. Now what we only need to do is basically map this thrower to our video screen. Again, there's a drag action that I just showed you, but if you select the video screen, you can see the sources where thrower 0 is selected as the source of this video screen. So let's create this thrower as the source for all 3 video screens, like so and like so. All right, so now if I drag the thrower around, you see what the thrower basically does. It throws the content to the viewport objects that are assigned to it. And of course, here in Frustum, you can adjust the field of view and so on. There are several types of throwers: cubic, spherical, orthogonal, and cylindrical. So please feel free to explore those. Now, the last thing that we need to do in this part of the tutorial is map these video screens to actual physical outputs on your system. So the way to do it is by opening output maps. Again, I can left click on this command or just press F6 and the window is going to open. As you can see, the output maps window is basically the same as canvas maps. It's just that in canvas maps you have canvases here and viewport objects here, whereas in output maps you have viewport objects here and outputs here. So first, what you need to do is create a virtual output. So let's create a full HD virtual output. And I'm going to map the virtual video screen to my physical video screen here. I'm going to change the resolution of this one so that it's the same as my output, like so. So now I have my virtual video screen mapped to the virtual physical output, and you can map this output on any physical output on your system. So on my system at the moment, there are 2 displays detected. Both are full HD. So you can simply drag like so and map it to one of my 2 monitors that I have connected to the system, or again, left click here and map it like so. The last thing that you need to do is left click here and click on enable. So let's just disable that on map. I'm going to map it to the same video screen that I'm using at the moment, and I'm going to click on enable. So now you see that the output, that virtual screen is output to the physical output on my system. All of the outputs by default have a setting enabled called always on top. So that basically prevents you to going back to accidentally have another window like Notepad or whatever appear on the actual outputs, which can be a pretty embarrassing thing on a live event. To disable that, you need to hold Control, Shift, and T, and you'll be able to Alt Tab back into the system. In most cases, you wouldn't map this virtual output to the screen where you have the user interface anyway. Also, the flashing that you saw before was because I'm using Creator Free version, and that's the watermark. Similarly to canvas maps, you can of course also use Shift and drag it like so. Again, rotate, rescale, all the things that we talked about in Canvas Maps window are the same here as well. Now let's talk a little bit about assets. If I open the assets window, you'll see that I don't have any assets at the moment. The simplest way to import assets at the moment is just to drag them from wherever you want them, wherever you have them on your hard drive, into the window, and it's going to appear here. You can also create collections and drag it like so and so on, organize it in any way you want. In 4.10, that's the next version of the software coming out in January 2025. There is going to be a big change in assets so you'll be able to use asset repositories, both local on your hard drive and remote or on a NAS system, on a NAS drive. So I won't be talking too much about assets because there will be separate tutorials when version 4.10 comes out. So now we have a video asset here, and you can either, again, create a video layer by holding V and left mouse button and select the asset here, or you can simply drag the asset like so, and it's going to offer you layer templates, which LightAct thinks are suitable for playback of video assets. So I'm just going to select the layer template. You can also drag an asset onto the layer, and it's going to assign the video asset variable to that asset. So I'm just going to import another video asset so we have at least two. Okay, so now we've covered how you can import assets, how you can organize them in collections. If you, for example, drag an entire folder, you'll also import all the video assets in that folder and already organized in a collection, and so on. One thing to note, in a lot of windows, you can see additional properties if you expand the size of the window. So if you expand the size of assets window, you'll see that LightAct supports versioning as well, and you can find out more about how to work with versions in our user documentation. And also here, for example, if the window is too small, you'll hide some additional. You won't see some additional properties. That's basically to reduce the visual clutter. Okay, so let's talk about sequencing. Most of sequencing happens in Timeline Editor window. Some of it might also happen in Timelines window, but yeah. So I'm going to map this video screen I'm going to map this video layer to this video screen, like so. And now you see that if I, that both of these layers are rendering to this video screen and respecting the order of the tracks, as we call them. So these are tracks and these are layers. So there are a lot of different ways you can start playing with sequencing. One of the common ways is to adjust the fade-in time, like so. For example, now the content is going to fade in, and you have a fade out as well. You have the blending modes in all of the in basically all of the content layers. You have various blending modes that you can play with. Another feature that is very useful in sequencing are sections. So you can insert a section by right-clicking and finding them in the menu, or simply by holding S and left-clicking. So sections are a way to organize your timeline into various parts, and each section has its own set of properties. For example, you can control master fade, master volume, things like that. But the most important, actually, and the most commonly used feature of sections is that they are used as a queue. And now we can introduce the queue list window where you see all the queues of your project. So I can create some additional sections like so, and you'll see that as long as this checkbox is checked, they appear in the queue list window. Now, again, if I expand this window, you see that there are some additional properties that you can play with. One of these is what happens when you trigger this section. So at the moment, if I click on these, you're going to see that the place state doesn't change. But if I, for example, set it like so, and if I click on the trigger, it's going to start playing. And if I, for example, you stop and click, it's going to stop. Another feature that is useful is called markers. And again, I can either right click or hold M and press. So markers are in a way similar to sections. They are a way of organizing the timeline without actually introducing layers. But markers have additional properties called action on playhead pass, which basically means that you can set that whenever a playhead hits this particular marker, something is going to happen, either a jump to the next marker or actually change the play state of this timeline. Markers also have the use as queue button, so they can also be used as queues in the project. Another feature that we should talk about is curve editor. So every property of a layer that you see here, most of them actually, can be controlled with curves, which is what you see here. So curve editor happens here, and if you select the property and enable the curve flag, you can create points on the curve. So basically this allows you to modify the properties of a layer through time. Another feature that you'll probably use a lot is syncing. So LightAct timeline can be synced to various sources, LTC coming from audio input, ArtNet timecode, MIDI timecode, and so on. And all of these settings can be adjusted in the properties of individual timelines. So LightAct can have, of course, several totally independent timelines. And if you select one of the timelines or click on an empty space in the timeline editor, you see the properties of that timeline. And all of the syncing properties are adjusted here. So what I'm going to do is, since I don't have any incoming timecode at the moment, I'm going to select that timeline 1 is being synced to timeline 2. So what's happening is that if I move the playhead of timeline 2, the playhead of timeline 1 also moves. Okay. So in the syncing section, you can set the behavior, what happens when there is no incoming TC. You can enable grace period, and what's very important, you can add TC offsets, where basically you can adjust the start timecode times that correspond to each individual section. So in a lot of live shows, for example, section 1 should start at, let's say, 30 minutes time code, section 2 should start at 1 hour, section 3 1 hour 30, and so on. And this is all adjusted in the syncing section of the timeline properties. In the beginning of this video tutorial, I mentioned that in LightAct, the layers are not just called layers, but they are called layer templates. So these are layer templates. And the reason for that is that you can modify them. And how can you modify them? Simply by either right-clicking and clicking on Modify Layout, or just by double-clicking on them. So if I double-click on this layer, you'll see that every layer is created with nodes. Which means that you can easily modify it to make it do something else. Furthermore, if you double click on an empty part of the timeline, like so, you'll create a blank layer. If you double click here, you'll see that it just has 3 basic nodes. This one triggers just once whenever the playhead reaches the layer for the first time, and this one triggers when the playhead exits the layer, like so. Tick, on the other hand, triggers every frame as long as the playhead is either in one of the play modes or in pause mode, and that it's on the layer itself. So you can, for example, make a layer do something like render to mapping, or maybe send UDP, and we'll talk about these things later on a bit more. Or set device state is something that people have been using a lot for optimization of the processing and so on. So LightAct's layer is a very, very flexible concept that you can modify yourself. So let's say you created your own layer that you sort of like and would like to use in other projects. So you simply right-click, template, and create template from layer. And this will basically save your layer template into the program data folder and LightAct. And this layer template will be available for you in all your LightAct projects. Another feature that I think is quite useful when it comes to content sequencing is what we call layer connections. So if I click Window and open Layer Connections window, you see that I don't have any layer connections at the moment. So one example of when you might want to use a layer connection is, what if you want to, for example, use the same texture that I'm using in this video layer, but also map it to this thrower. Now you can use another video layer playing the same video file to map it to this thrower, but that wouldn't be optimized because you would read the same video file twice. You could probably also use canvas maps, but what you can also use is what we call layer connection. And to demonstrate this, I'm going to use a generative layer template called texture to mapping. It doesn't by itself do much, and it has very few properties here. So what I'm going to do is hold Alt and drag from this layer to here. And what this does is basically takes the texture property, the texture variable of this video layer, and copies it over to the texture variable of this layer. Now, if I map this video layer to the thrower, you see that now the video file that is being read and played back by this layer is rendered directly to the video screen here, but also copied over to this layer, which is then mapped to this thrower. And you see that a layer connection has been created. Once you start playing with layers and start to modify them, you'll also find that you can transfer any kind of a layer variable from one layer to the other simply by using the layer connection window. In most cases, you'll probably be using layer connection to transfer textures from one layer to the other, but the feature can be used for other things as well. Okay, since we mentioned UDP, we can perhaps start talking about how to get data and content into LightAct from external sources. This is done through the devices window, which you can either open here or just by pressing F7. So let's create an NDI receiver, for example. I'm just going to type in NDI receiver and so on. And I already have one sender active on the network. I'm going to select it and click on receive. Actually, this is the right one that I wanted to show you. Yeah. So this is the texture that's coming in from NDI sender. And you can, of course, use other like UDP receivers and so on. So this is basically it. We created an NDI receiver node and let's say a UDP receiver node. Now, how do I get this texture into the layer system of LightAct? You do this by layers, of course, and we created a layer template for you. It's called content input. So let's create it. And in here, in the properties, let's map it to one of the screens to set up the mapping. And here, I'm going to select the device that I want to use as the content input. By the way, you can also hold Alt and drag it, and it's going to do the same thing of setting the device variable to the NDI receiver. Similarly, I can create, let's say, a receive message layer template like so, and use the Alt approach like so. And now you see that the device property is set to UDP receiver node that we created, and every message that is going to appear that is going to be received by UDP receiver is going to be also received by this layer. Now, if I double click on this layer, you'll see that there is a layer template that we've set up for you, and you can modify it to make it do whatever you want it to do. Okay, so now that we've covered the majority of sequencing and the devices, let's talk about another very important feature, and it's how you can control LightAct using incoming DMX. That's a very common use case when you have a lighting console on an event and you want to use that lighting console to control LightAct. So first thing is that you'll probably want to open the DMX in window. And if you see here, you can see that it has the universe selection and it has the DMX values grid. Here you can also set up how LightAct is listening to the incoming DMX, either through ArtNet or streaming ACN. And here you can adjust to which DMX channel a particular layer is assigned to. So let's see how this works. I'm just gonna start by saying that every layer has a DMX category of variables, which is by default set to -1, which means that this layer is not going to be controlled by DMX. Drag from a particular DMX channel onto the layer, you'll see that these two variables change and they show basically the channel and universe which is assigned to this layer. Now you see that if you hover above the colored grids, you'll see which variable of that particular layer is assigned to that particular channel. And you can control which layer variables are controlled by DMX using this flag here. And if you right click on it, you'll see that you can also adjust encoding and so on. Now, in most cases, since you'll probably be using the stock layer templates, these will have been already set up for you by us. So you shouldn't really modify the encoding, for example. But if you don't want, for example, that your layer takes up so much DMX space, even though you might want to just control one property, you can simply do like this, and it's going to be using less. It's going to have a smaller DMX footprint. You can also use auto patch layers, which will automatically patch all the layers that you've created in all the timelines to the DMX, to the incoming DMX. Next feature that you'll probably want to explore is called control by DMX. We might rename this in the future, but at the moment it's still called control by DMX. So if you click on it, you'll see that, and I'm just gonna assign it to universe 2, like so, and I'm going to open the DMX like so. So you see that if I disable, you see that when it's enabled, individual channels get colored with LightAct green color, and you see what each channel will do. So you have several sort of categories of commands that LightAct listens to, and contrary to DMX in window here, for example, where we are controlling individual layers with DMX, with control by DMX, you can control like a general state of LightAct. For example, at the moment here we have a master fade, here we have video output fade, here we can control the play state of timeline 1 and the play state of timeline 2, and control cues from the cue list window. Control by DMX is useful for general control of these things inside LightAct. Another interesting thing that's related to DMX, but not only to DMX, is what we call indexing of assets and objects inside LightAct. So let's say you want to control which video asset this video layer is going to play through DMX. So if I enable the DMX flag on the video asset, it means that one of these channels will be controlling the video asset. And because the encoding of this variable is set to 16-bit, it means it's going to take up 2 channels. Now, how are these 2 channels used? And that's done through Index Manager. So all of the assets here are categorized or organized into collections and into indexes or slots. So if I click on autofill here, you're going to see that at the moment we are in collection 0, and all of the video assets that I imported previously have been organized sequentially. So if the incoming DMX is 0 for collection 0 and 0, so if we are receiving 2 zeros on the 2 channels that are coming in, this video layer is going to be playing this video asset. And if we are receiving 0, 1, it's going to be this one, and so on and so forth. LightAct also allows you to, by naming the video assets in a certain way and by naming the folders of the assets that you have on your hard drive and that you have in terms of the collections here, to automatically import them into the correct collection and into the correct index of that collection. You have different you have different collections for different asset types, so that, for example, if you're using a notch layer, the asset of the notch asset is going to be found from within notch block collection type. Similarly to how we have DMX in window, we also have OSC in window. Again, this is used to control layers through incoming OSC. So if I click on regenerate button, you'll see that all of the layers, all of the variables of all the layers that have OSC flag selected will get its own USC address that you can use to control that particular variable. Similarly, we also have a control by OSC window where you have the main sort of properties of LightAct accessible through incoming OSC. So this means that master fades, master volumes, the place states of every timeline, and of course the queue triggers from the queue list window can all be controlled with incoming OSC. Okay, so let's talk about projection mapping. LightAct has really a lot of features for projection mapping, so let's start with them. I'm gonna create a very simple, let's call it projection mapping project. So I need a cube like so, and I'm going to create, let's say, 2 projectors or maybe 3 like so. And I'm going to assign this primitive as a source to this projector simply by dragging like so. You see how the viewport has a red border, and then when I drag onto the compatible object, it turns green. That means that it's a compatible object. So now all of these projectors have this primitive set as the source, and you can see this also in here. So if I hold Shift F, it's going to turn towards its source object. So I'm just going to select all of them and move them a bit up and Shift F so that they all see this primitive. Okay. So now these projectors see this primitive as its source, and you can output it. If I select here, you can see that I can output them directly into one of the outputs in the output maps window. So one of the first things that you'll probably want to do when you're actually on site with your projectors, you'll want to calibrate them. So for this, you need to have a virtual model of your projection object that is exactly the same as the actual projection object. Once you have that, you double click on your projector, and in the 3D cal, you can calibrate the projector so that it matches precisely the physical projector. 3D cal workflow is going to be upgraded a bit in 4.10, so I'm not going to go into too much detail on how 3D cal works in 4.9. LightAct also offers camera calibration, and it's called Iris, where we support camera calibration with our cameras called LightAct cameras, but we also support camera calibration with OptiTrack cameras, where it's also possible to use active and passive markers embedded in the projection object, and that allows you for more automatic calibration. Once you've calibrated your projectors, you should see, if you have an actual projection setup, the content should fall on your projection object almost perfectly. The next thing that you probably want to do is called auto blending. And if you open the auto blend window and select the object that you want the blend to apply to and click on blend, LightAct is going to use the 3D information from your viewport to calculate blend masks automatically. There are several settings here that are further explained in our user documentation. Now, regardless of how precisely you do the calibration, it is very likely that the content is not going to fall 100% perfectly on the object. So that's why we've enabled additional fine-tuning tools if you right-click and click on Setup, or simply if you double-click, where you can see the layout of this particular projector. And you see that here you've got several additional nodes that allow you to warp the content, to blend the content, to add perspective warp, and do like texture masking, all of these things. LightAct also offers projection study, which you can enable simply by going here, and you add all the projectors you want to basically study, and you add the object that you want to study on, and when you click on enable, you see the how the whole thing will look. You can study the shadow analysis, illuminance, with the scale being shown here, and also pixel size is useful, which allows you to, when you zoom in, to really see how the individual pixels, how much they will be stretched. By the way, if you hold Control while zooming in and out, the zooming step will be much smaller, as opposed to if you don't hold Control, then the zooming step is larger. And lastly, in the projection tools, we also have PJ-Link, where you can send command to scan network, find all the PJ-Link compatible projectors, and also send various commands to it. We also have, there's also a couple of nodes that allow you to send PJ-Link commands from within a specific layer, which is useful for several things. LightAct also allows you to send DMX directly to DMX fixtures through ArtNet or streaming ACN. So how does this work? First, you need to have a couple of fixtures. So we've done that already for you, and you can see them in Fixture Editor, where you see we have these templates, for example, generic 10 by 1, 20 by 1, things like that. And in this window, you can arrange you basically modify an individual DMX fixture. And so you can use, you can determine the pixel type, the pixel arrangement, whether it's grid circle or completely custom, number of columns and rows and so on. And you can also connect the pixels, which basically determine how the DMX addresses progress through the fixture itself. Once you have the fixture done, you can insert it by dragging into the viewport like so, or let's create actually that one, the 8x8. And I'm going to enable a content override like so. And if I map this thrower to this fixture, you see that it is the content is being mapped to this fixture through the thrower. You can map content to a DMX fixture with throwers, also through canvases, although that's not the preferred workflow at the moment because it's a bit hard to manage the usually bigger resolutions of the canvas with very small resolutions of individual fixtures. And that's why we also have a node called DMX by UV, where you can basically use a 3D model of an object, of a properly UV mapped object, and through a CSV file, you map an individual UV coordinate of that object into a universe and channel of DMX. This particular node is very useful for complex 3D arrangements of DMX fixtures. Once you have a DMX fixture in the viewport, you can determine the start universe and start channel, which is going to be used to send out the DMX from that particular fixture. In a lot of projects, you need more than one server. You can manage server cluster in what we call LightNet. So at the moment, there's one LightNet window where you can see all the servers on the network. In the future, in 4.10, there's going to be 2 windows here. So we're going to create a separate tutorial for that. LightAct has a very good integration with Unreal Engine, which is set up in UnrealLink window. If you want to learn more about that, there's a separate tutorial for Unreal Engine integration. These 2 windows, project settings and preferences, are definitely worth to explore. Preferences is something that you set up and should be valid should take it in effect into all your LightAct projects, whereas project settings, of course, relate to individual project. And to conclude, I hope this video tutorial was informative and useful to you. It's not designed for a complete explanation of every possible feature and setting LightAct offers. It's designed to give you, however, an overview of where things are so that you can start playing with them and are able to find more information about these particular features in our user documentation. If in case of any questions, please contact us directly. We have various channels you can reach out to support@lightact.com. We have our Discord server. Enjoy using LightAct.